Hello, everyone who has joined already. We'll give it another minute before we start. Okay, it's time to start. Good morning, everyone, and thank you for joining this webinar. As AI adoption accelerates, testing alone isn't enough. You need secure, governed, protection realistic data. Traditional approaches can't keep up, and with regulations like NIST, the stakes are even higher. So today we are going to explore a better way. I'm joined here by Connor Thompson from Resilient and Finn Lofford Mee from Synthesize, who will show you how AI native test data automation can reduce risk and help you scale AI assurance. We like to keep these sessions interactive, so we've got a couple of polls for you coming up, so keep an eye out for those. And please feel free to pop your questions into the chat as we go on, and then we'll pick them up after the presentations. I would also like to remind you that this webinar is being recorded and you will be sent a recording tomorrow or the day after, so you can rewatch it or share it with colleagues. So that's all for me. So with further ado, let's get started.
Brilliant. Thank you, Catherine. So today I want to walk us through the agenda of what we're going to cover. So we'll start with what AI assurance actually is, and it's a distinct discipline, and it's important to be clear about how it differs from traditional QA or governance consulting. From there, we'll look at the regulatory landscape, specifically how NIST, the EU AI Act, ISO 42001 and GDPR converge around AI assurance obligations. Then we'll focus a bit more deeper on NIST specifically, the 6 key considerations it creates for organizations running AI systems and specific assurance activities required. After that, we'll walk through how those assurance activities map across the software development lifecycle, where they land, who owns them, and what standards actually apply. And then finally, we'll bring in Finn to show how test data management and synthetic data become the practical enabler for all of this, especially where PII is involved. There'll be time for questions at the end, as Catherine mentioned, so drop anything into the chat as we go, and we'll look to address those at the end. Let's start with the foundation. What is AI assurance and why does it exist as a distinct discipline? This matters because there's a lot of confusion in the market. Organizations hear AI risk and either reach for their software testing team or their governance consultants. Neither of them is the right answer on its own. So we want to be very clear about what AI assurance is and what it isn't. This slide captures the three distinct disciplines that organizations often conflate, and it's worth spending a moment on each of these. Traditional software QE works with deterministic systems. The logic is fixed, the outputs are predictable, and pass and fail testing makes sense. If you put X in, you get Y out, and that usually happens every single time. That model completely breaks down when it comes to AI. Now, governance consulting, on the other hand, operates at the policy layer, where framework design, accountability mapping, audit documentation become essential, but it doesn't tell you whether your model or your data is actually safe or behaving correctly. AI assurance sits between both of these worlds, and it goes beyond both. It addresses probabilistic output validation because AI doesn't give you the same output twice. It covers bias and fairness testing, explainability validation, model robustness, data quality and lineage, and regulatory compliance evidence. The key phrase here is total quality of AI. That means assuring not just a function, but behavior, safety, fairness, compliance across the full life cycle of the AI development. This is the discipline Resilient has built capability around, and it's the lens through which everything else today should be understood. So moving on, what you have in front of you is the AI assurance stack. This is a way of visualizing how traditional QE capabilities and AI-specific assurance capabilities layer on top of each other. At the base, you have your deterministic traditional QE layer. So that includes functional testing, non-functional testing, acceptance testing, the typical activities that you would expect within the SDLC. These capabilities still apply to AI systems. They're necessary, but they're not sufficient in their own right. On top of that, you need AI-specific capabilities. This includes data assurance, ensuring that the quality, provenance, and representativeness of training and test data, the model QA. So this is validating that the model behaves correctly, it's robustly, it's fair under diverse conditions as well. And wrapping the whole stack is essentially responsibility assurance, which ensures that the system as a whole is explainable, auditable, and accountable. This is where the regulatory evidence is ultimately produced. The important point here is that you cannot treat AI assurance as just another testing phase. It requires a fundamentally different capability set. The organizations that skip to the top of this stack without the foundations will fail both their assurance obligations and their regulatory obligations too. So talking about regulations, let's have a look at the landscape of the regulatory landscape. This section is about understanding why AI assurance has become a compliance obligation, not just a best practice, and specifically how NIST 2 creates direct obligations for organizations operating AI systems in critical and important sectors. We're going to start with a quick primer on NIST 2 itself. So NIST 2, as I hope everyone is aware, is the Directive on Security of Network and Information Systems, and it came into force in October 2024. It applies to essential and important entities across 18 sectors, including energy, transport, health, financial infrastructure, digital infrastructure, and more. The key requirements it imposes are risk management, incident detection and reporting, supply chain security, and governance accountability with personal senior management liability. The penalties here are quite significant, up to 10 million euros or 2% of global turnover for essential entities. So it's quite important that the approach to assurance here is correct. Now, why does this matter for AI specifically? The directive was written with cybersecurity in mind, but AI systems, when they are embedded in essential services, fall directly under its scope. An AI model failure or failure in data in a critical service is an security incident under NIST 2, A compromised training data set is a supply chain risk. A board that cannot demonstrate oversight of AI risk is in breach of the governance requirements of NIST 2. The 4 AI-specific impacts on the right-hand side of this slide summarize it quite clearly. AI failure equals security incident, supply chain risk, governance and accountability obligations, and security of AI assets. Each of these has a direct assurance implication, which we'll come to shortly. Moving on. This table is one of the more important in today's deck. It shows where the major regulatory frameworks converge on AI assurance requirements. Now, while the focus of today's session is NIST 2 and specifically around data, it doesn't mean we forget about the other regulations and standards that are in place. So reading across each row, you can see how a single NIST 2 obligation maps to parallel obligations in things like the EU AI Act, a control in the ISO 42001, and a GDPR requirement, and what assurance activity that convergence demands. I'm going to call out a couple of sections in the table in front. So looking at risk management under NIST 2 Article 21 aligns with the EU AI Act's risk management requirements and ISO's 42001's risk planning clause. The assurance response is to do an AI inventory, risk classification, and model risk assessment. And then if we look at the supply chain security, this maps to provider obligations in the EU AI Act, the supply chain controls in the ISO 42001, and the precursor agreement requirements under GDPR. Again, there's an assurance response to all of this, and that is third-party AI audit and data provenance assurance. And then if we look at one more of these, the security of AI assets, which sits at the intersection of the NIST 2 Article 21, the technical requirements of the EU AI Act, and GDPR's data by design principle. Again, one of the responses here is security assurance, things like penetration testing and adversarial AI testing, the type of activities that you would want to consider here. The key message that we're trying to get across is that these frameworks are not competing, they're converging. An organization that builds an AI assurance program aligned to this table will be positioned to demonstrate a compliance across all 4 frameworks simultaneously, rather than focusing on just one. So now we're going to jump a bit more into the specifics. The next section focuses on NIST 2, what NIST 2 actually requires organizations to address when AI systems are in scope. We've identified 6 key areas where AI creates particular challenges and where the directive creates particular obligations for organizations. These aren't theoretical, they're the considerations we see organizations struggle with when they start mapping their AI estate against NIST 2. So I'm going to walk through each area very briefly. First area is AI as a critical asset. If you're using AI in, let's say, fraud detection, grid management, clinical triage, or any other function that constitutes part of an essential or important service, that AI system must be classified and treated as a critical asset. That triggers the full range of NIST 2 risk management requirements. Secondly, unpredictable failure modes. AI doesn't fail like traditional software. It fails through bias, through hallucination, adversarial attack, or silent drift. And standard incident detection mechanisms don't catch these. They're not programmed, or they've not been developed to catch those. This requires AI-specific monitoring capability. Then we move on to supply chain AI risk. Most organizations are consuming third-party AI. So this would be things like pre-trained models. It could be cloud AI APIs, LLMs from the major providers. Under NIST 2, these are all part of your supply chain and you're responsible for their security. Most organizations have no formal assurance of these dependencies. They just take at face value the protections provided by the suppliers. Moving on to incident reporting timelines. NIST 2 requires a 24-hour early warning and a 72-hour full report. AI events, including model failure, data poisoning, prompt injection, must fit within that framework, and that requires predefined playbooks and detection signals in order to know when any of those actions have occurred. Then we move on to governance and senior accountability. NIST 2 makes senior management personally liable. Boards cannot delegate AI risk to IT. They need to demonstrate oversight, and that means structured reporting on AI risk across the organization. Then finally, we come to business continuity for AI. If an AI system fails in a critical service, what's the fallback? Retraining, roll back to a previous model, fall back to deterministic logic. None of these have traditional BCM equivalents. They need to be designed, tested, and documented. So that comes to the end of this. We're going to now move on to a bit more of a deep dive into the assurance activities that Resilient delivers to address each NIST 2 obligation for AI systems. I'm not going to read through every row, otherwise that would take some time. But at the foundation, you have AI asset classification and AI risk assessment. These establish what you have and what risks it creates. They're the prerequisites for everything else. It's one of the most important activities you want to perform as an organization. Then we'll look at something like third-party AI audit. This addresses the supply chain gap that we discussed earlier, assessing pre-trained models, the AI APIs, and the cloud machine learning services for security, provenance, and compliance against NIST 2. AI security testing covers the AI-specific attack surface, so things like adversarial robustness, prompt injection, model inversion simulation, and AI-specific penetration testing. I'll cover one more. And if we look at the AI governance framework, this translates board-level accountability requirements into practical structures, things like ownership registers across the organization, senior reporting, and management liability alignment. Together, all of these activities constitute a complete NIST 2 AI assurance program. The question for most organizations is where to start. Typically, it's with a classification and risk assessment, which then establishes the baseline for everything else to build from. So that's why I wanted to highlight that as a key area to start from an assurance point of view. So now we want to look at how these assurance activities sit within the software development lifecycle. One of the most common mistakes organizations make is treating AI assurance as a gate at the end of the process, rather than a compliance check before go live. That approach fails because by the time you've reached that gate, the problems have already been baked in from the beginning. AI assurance needs to be embedded across the full development lifecycle, and this next slide shows you exactly where each activity would land. So here's the full SDLC map to NIST 2 aligned AI assurance activities. Starting at requirements and design, this is where you do your AI asset classification, your threat modeling, your NIST 2 obligation mapping, and supply chain risk assessment. If you get any of this wrong, and everything else downstream then becomes misaligned. Data preparation, this is the critical phase that is often underestimated. Training data quality assurance, bias and representation audit, data provenance validation, privacy and DPIA alignment, data poisoning risk review. All of these must happen before a single line of model code is written. The data is the model's foundation. If data has problems, the models will also have problems, which is a big focus of today's session. From a model development point of view, that's focusing on things like robustness testing, adversarial attack simulation, performance metric validation, and explainability checks. These are AI-specific activities that go well beyond functional testing and cannot be covered with traditional methods. However, then we look at testing and validation, and this brings together functional, non-functional, and acceptance testing into the full test suite and produce the compliance evidence pack that demonstrates NIST 2 readiness. Finally, on the far right side of the SDLC in deploy and operate, this is where ongoing monitoring lives. Things like machine learning operations, drift detection, and NIST 2 incident classification. Assurance doesn't just stop at deployment. The key message is shift left on AI assurance, just as you would for security. You want to bake that in and do secure by design as early as possible. And the later you find a problem, therefore the more expensive it is to fix. So that's why there's a big emphasis on those early stage activities. This matrix is the operational detail behind the previous slide. So how does that slide then translate into the different stages, and how does that map against the different regulations? For each assurance activity, it shows the SDLC phase, the NIST article it addresses, and the applicable standard, framework, or regulation, plus who should be owning it within your organization. A few ownership points are worth calling out here. So looking at AI asset inventory and classification. This sits with your CISO or risk functions within an organization. It's a risk management output, not a QA output. It's not expected that the QA team would be the ones that perform this type of activity. Bias and representation audit requires AI, QA, and ethics capability. This is, again, not a standard QA skill set. These are more SME skills and knowledge that need to be acquired. Drift and anomaly monitoring is a machine learning operation and SOC responsibility. It requires integration between the machine learning operations team and the security operations center. And then finally, if we look at the AI instant classification reporting, this falls again under the CISO and the SOC, who own the obligation to the regulator. This matrix can be used directly as the basis for an accountability register, which is one of the first documents a regulator or audit would ask for. So this is the type of thing that you'd want to generate and then provide to an auditor. Now I want to focus on PII specifically, because it sits at the intersection of every regulatory framework we've discussed today, and it represents a qualitatively different kind of risk in AI systems. The reason PII in AI is a distinct risk is captured in the paragraph at the top of this slide. AI systems don't just process personal data, they learn from it, they encode it into model weights, they can reproduce it in outputs, and they can expose it through interference attacks. So I want to walk through the 4 specific risks that this slide highlights. First is training data exposure. A model trained on real PII can memorize and regurgitate that personal data verbatim. There are already published examples of large language models reproducing names, addresses, and other personal data from training sets. Some of you may have seen recent articles or blog posts where people have been able to identify specific information of real people, which is quite dangerous. Second, model inversion attacks. An adversary can reverse engineer training data from a deployed model, extracting PII that was never meant to be accessible through the interface. Thirdly is bias encoded from PII. Personal attributes embedded in training data, things like age, gender, I can't speak, apologies. Things like your age, gender, personal details, including address and where you live. This produces discriminatory model outputs. This is a fairness issue and a regulatory issue simultaneously. Finally, test and development environment risk. Real PII is routinely used in AI development, test, and QA pipelines. These environments have far weaker controls than production. No access management maturity, often accessible to contractors and third party. Typically, this is where data breaches happen. They don't often happen against the production environment. They happen against the lower environments where security controls have not been considered or implemented as thoroughly. And with organizations often using cuts of life and maybe not always obfuscating that data, that opens up a huge risk. Now, the answer to all of this, as the call out at the bottom states, is not just better controls around real PII, it's eliminating real PII from AI pipelines wherever possible. And this is exactly where Finn would come in and Synthesize as an organization. So I just want to cover one more slide from my point of view. This really starts to show the convergence point of both Resilient and Synthesize. the place where Resilience AI assurance work and Synthesize synthetic data capability come together to solve the PII problem at source. On the left-hand side, Resilience NIST2 and AI assurance activities, things like identifying PII and training data, classifying it as a NIST2 critical asset, running GDPR, DPI alignment, and detecting bias encoding from PII. All of this are the type of activities that Resilience would perform as an organization. And then on the right is Synthesize synthetic data platform, replicating PII statistically with no real personal data in pipelines, enabling safe AI development and QA testing, supporting realistic bias testing at scale, and implementing GDPR data minimization by design, which we'll actually get a short demo on later as well. At the center, PII itself, so encoded in weight models, exposed via inference, introducing regulatory liability, driving discriminatory bias, present in dev and test pipelines. Then finally, at the bottom is the combined outcome. AI tested with no real PII in scope. Things like the NIST2 Article 21.2, risk, things like the GDPR Article 25, data minimization by design gets covered. The EU AI Article 10, training and data compliant, and then an audit-ready PII protection evidence available to your organization. This is a genuinely powerful combination. Assurance identifies and classifies the risk. Synthetic data eliminates it at source. Now I want to hand over to Finn to walk through his platform in a bit more detail and give some information on Synthesize.
Brilliant. Thank you so much, Connor. Before I go into test data, I just actually want to do a quick poll just to kind of see the different challenges from a test data point of view that many of you face. So if you wouldn't mind, should take a second. It would just be interesting to see. Already I'm seeing a theme. And yeah, I wasn't surprised that that makes a lot of sense, and that's consistent with what we normally see anyway, as having test data as an issue across the whole organization. So yeah, I'm going to really talk to you about Synthesized in this context is of course around AI assurance, but to the fact that everyone in the poll has said that they have test data issues as a whole, we do cover that as well within our platform. So if I just go to the next slide, so really want to talk about what Synthesize does and kind of why our platform's different and how we can solve these challenges. So ultimately, we want to sit as a universal TDM control plane. And what does that mean? Well, at the moment, a lot of organizations, and even between organizations, they sort of solve test data in different ways. And we kind of want to bring that all into one platform. Okay, so what we do is we actually have our own machine learning models to do a lot of work upfront for you. And that allows us to do synthetic data generation, but also masking of PII data, which is kind of what Connor also alluded to. We can also do subsetting as well, scaling data down when you have too much of it. And how do we do this? So essentially, we connect to a source system, or it could be a system, could be actual production environment. It could just be a schema if you're working on new systems, new features, and you don't have a production system yet. Or kind of we can also input other kinds of data like specifications and information from people's heads, essentially, to kind of build up what the data model looks like. Now, what happens within the platform, and hopefully I'll get to show you a bit of this, is that our models, our AI models, basically do two different types of scans on that data. So let's just say it is production data. The first part of it is they're doing scans to understand the data structure itself. So, the schemas, the tables, the columns, constraints within the database, data type, things like that. And that allows the system to basically replicate and make sure that everything is valid for the target output. However, the more impressive piece is really the second part of what it does, which is statistical analysis. So essentially, the system is doing analysis on the distributions of data, the patterns, the ratios, the weightings, all that kind of stuff. So that even when you're generating data completely synthetically, it actually still has the attributes and characteristics of your production data. A lot of the challenges that we see in organizations are that, the only option they have is to use production data, because if they try to generate it synthetically or mask it, it essentially completely changes the makeup of that data. And so then it's not representative of what they want to test. So we really try and plug that gap and make sure that we can make everything completely compliant, completely safe, generate it synthetically, whilst making sure that you can basically still mimic all of the characteristics of your production data. A couple of other aspects to talk about in this middle box here of how we do that. So our models do a lot for you in that sense, but you can still change everything as you need. So if your production data set has a lot of bias or distributions in a certain way and you want to change it, you have the flexibility to adapt it and change it as you need. So it's kind of a best of both worlds, I like to think, where we automate and do a lot for you, but then you can change and customize everything depending on what you need to test. Excuse me. Equally, we comply with all the policies that Connor basically has gone through today, and much wider as well. And ultimately, we want to make sure that last point is kind of really key, that users can have the right data at the right time when they need, and that's particularly important across shared environments when you've got lots of different teams working on one particular environment, making sure that they can all have the data they need without conflicting each other. Only other point I'll make on this slide is that we can connect into your entire ecosystem. So whether that is purely just on the AI assurance piece, or whether we can also connect into things like CI/CD pipelines, test automation tooling, whatever you have in your environment. Next, I want to talk about specifically, how we can actually make sure that we can generate data for the two key scenarios. So one is around training data, and the other one is then testing AI itself. So typically, the flow of this would be you define your scenario, and you can define that in plain config, and then what you can do is you can generate the exact data you want. And as I've already mentioned, that what we want to do with that is make sure that's balanced data and that it has no PII in it. So you have a number of options that you can go down. So if it's purely synthetic data, it's naturally not going to have any PII because you're generating it all from scratch. However, if you wanted to mask that data, we can ensure that only the sensitive fields are being transformed and changed. And the balanced piece, like I said, is really because if you want to change distributions, if you have bias and you want to kind of align that, and change that, we can do that in that scenario. Once that's done and you've generated the data, you're then going to run your test, the AI under test, and whether that is a RAG system, an LLM, a custom model, whatever it may be. And then you're going to obviously check the result, pass, fail, or did it drift. Now, the really big value add here is the green bar kind of underneath that, which is that for regression testing and repeatability, you can generate the same data over and over again. And again, that's really important for AI because, as we've already spoken about, one of the key issue is hallucination, bias, all of that stuff. And so you want to make sure that you're feeding in the same input, so you're testing the same output, and that is consistent with your results. So you can generate the same scenario over and over again, and you can do that with lots of different teams, etc. Like I alluded to, there are two parts to it. So one is actually training data and being able to fix biases before it reaches the model. So you can customize and change it. And I can show you that in the demo. And then the other one is actually testing the AI itself. So that repeatable loop where you can keep testing it with the same scenarios, but also edge cases as well, as and when you need. So what I'm going to do now, because obviously it's been a lot of slides, is I'm going to go into a short demo of the tool where I can actually show you, what the tool looks like and how it works. So I'm just going to share my screen, and hopefully it will come up in a second. I don't know.
Napur, can you make Finn's share live, please?
Thank you. Perfect. So the system itself, we've tried to make as simple as possible and easy to use as possible. Now, there are lots and lots of different features, and because of time, I'm only going to try and focus on the core and important ones here. So essentially, you can think of the system in 3 layers. So we have the concept of organization, projects, and then workflows. So workflows are basically the way in which we define how we want data to be transformed, and then we can organize those into various different projects. You can see here, my projects are quite random, but typically most organizations group these into different applications or use cases. These can also be locked down, as you can see with little locks here, user controlled. You can control which data sources are accessible from them, etc. What you can also do from a wider perspective is we can integrate into SSO, basically any identity management tool you have in your environment. So what I'm going to do is I'm going to go into an example project, and I'm going to show you a synthetic data generation workflow. Now, what I'm going to show you is that the workflow has 2 different views. So you have one which is more of a visual view, which is a database view, and then we also have the kind of configuration that I alluded to in the slides here, which is basically data as a code, we call it. It really just depends whether you're a technical or non-technical user as to which kind of route you want to go down. But the important thing is generally all of the stuff you're seeing here is by exception, not by default. So here, for example, I've actually added some kind of custom rules and business logic within the code, but the system will apply pretty much everything else for you from a kind of database perspective. So what I can do is I can come back into the database view, and what's actually happened is, as you can see what the AI has scanned, right? So we've got a schema, we've got tables, we've got columns, we've got the database, the data type, the sensitivity, and we also have kind of relationships as well that have been picked up between columns as well. The really key bit is this kind of middle section, which is the transformation. So what's basically happened is after the AI has connected into that source system, it's done those 2 different scans that I mentioned, and it's then applied one of our generators to make sure that it can mimic that data exactly. Now for fields where it's appropriate, it's also applied that distribution that we mentioned. So if I come down into something like customers and we go into customer type, if I open this up, what we can actually see is that we have the distributions that have been automatically assigned to those customer types. So we've got non-profit, government, individual, VIP, and business. Now, this is where it's completely customizable. So, I could say actually for my particular test, I want to see what would happen with 90% business accounts, a massive flood of business customers. But equally, if this was something like a gender field, I could switch the bias to make it 50-50 as an example. And again, that really depends on what exists in your input and kind of what data, what the distribution looks like from that source as well. But everything here is customizable. What we can also do from a synthetic data point of view is choose how much data we want to generate. So, it could be for performance testing. It could just be to get much larger scale of data, much more richness of data. But we can also scale data down as well, because sometimes, certainly when you're connecting to production environments, they may have terabytes and terabytes of data. We can actually scale that data down, but whilst keeping the distributions kind of as they should be. So you still get the attributes and richness of the whole data set whilst having it much smaller as well. So we can do that either through the config, the code, or we can do that here in the workflow settings. I can either do it through a target ratio or I can do it through a target row number. So I can choose here, I want 5 times the amount of data. So here I'm scaling it up. I could also do a number below 1 and scale it down by 50%. Or I could actually go in target row number and say, I want 1 million rows, 1 billion rows, whatever it may be. Importantly, we can also do this at a table level as well, and that's important from maybe an AI model perspective. If you've got your AI and it's there's only certain parts of the data that you need to focus on, or you need to sort of adapt and change, we can control the levels of how much data you want to have for each table as well. And equally, we can do the same with modes. So at the moment, I'm looking at everything is being completely synthetically generated, but I actually could just choose that I want one table generated, and actually that I want other tables to be masked from a PII perspective as well. The other thing I'll show you is around that kind of PII piece. So like I've also alluded to, we can do masking, where you only want to mask or sort of transform those sensitive fields. So we can do that by running a sensitivity scan, and this scan utilizes our machine learning models, looking at different elements like column name, samples of data within there as well, to basically give you a report of what's deemed sensitive and what's not. And within here, we can also then change those things as well. So it's kind of human validated, and then it remembers your choices as well. Of course, because I'm running a live demo, it's taking longer than it should, but I think I might be able to show you on another one. It working, but essentially it comes out with a report of things that are deemed sensitive, not sensitive. You can then validate it and change it. And the biggest value add here really is that this may not show now, but I will show you the end result. Oh, okay, there we go. Okay, it did just say repeat complete. No. Okay, there we go. So yeah, so now we can see, all the different columns, the tables, and we can see the sensitivity applied. And I can come in and I can change these as well. And it will remember what I've picked as well. The biggest value add here is when you're working with incredibly large data sets. As a one-time exercise, you can come in, you can choose what you think sensitive, or again, you may have in your organization or industry particular things that are deemed as sensitive that are maybe not in the wider space. So we can also kind of configure that and change that as well. But then the real value add is clicking this button here, which essentially will, excuse me, apply a masking routine to each of those fields marked as sensitive. So yeah, at scale, this is a massive time saver. And if I click that button, of course it is because I'm in the wrong workflow. But yeah, what I'll do is I'll show you in here, in this one, what we can see is that lots of fields that are not marked, that are not sensitive, are being marked as pass through. So they're literally just going to be copied over value as they are. And then the ones that are deemed sensitive, if I come down here, first name, last name, email, we can see they're now being transformed as well, to make sure they don't have any PII data. Now, these are all being transformed with the kind of an appropriate masking routine, i.e., everything's still going to be in the same structure and be valid from a schema point of view, but it's also just going to be kind of scrambled, if you like. We can also customize everything about how it's being masked if we choose to, but the system is going to select a sensible default for you at the start. The only other thing I will mention is that we can also do what I call realistic masking. So what that looks like is basically overlaying our generators with those columns in a masking routine. So here we can see that those same fields are being transformed, but now they're using a person generator. So, a customer name of Finn is now going to be transformed into William. And the really important thing around our models within the platform is that they are deterministic. So that's really how, going back to the slide I was showing around repeatability, we can make sure that with every same input that you have, you are guaranteed to get the same output. And that's why within our platform, we don't utilize LLMs and we have our own kind of statistical models. So we can make sure that that is repeatable. But also on a wider scale, it also means that we can scale the system in very interconnected ecosystems. When you've got the same kind of data in lots of different systems that work together, we can connect Synthesize to each one, and you can then kind of have that confidence that Finn is always going to turn into William, and so then that it makes sure that it doesn't break the overall flow. So that's all from me. I'll hand back over to Resilient.
Brilliant, thanks, Finn. So I just want to transition to the final slide. And that brings us to the end of today's session. Thank you to everyone who joined, and in particular to Finn for walking us through the Synthesize platform. Hopefully it was really useful for everyone watching to practically see how to supercharge your test data in your environments. The core message to take away is this: NIST creates real obligations for organizations running AI in essential and important services. Those obligations span risk management, supply chain, incident detection and reporting, governance, and business continuity. They also require AI-specific assurance capability, not just traditional QA or governance consulting. You need to combine all three together. And the practical enabler that makes all of this workable, particularly around PII, is the synthetic test data, eliminating real PII at source, as Finn demonstrated, and you eliminate a whole class of regulatory risk once you are able to achieve that. If you'd like to discuss your own NIST2 AI assurance position or explore how synthetic data could support your AI development pipeline, please do reach out to myself or Finn. And our details should be on screen. Yeah. If there are any questions, please drop them into the chat, and thank you. Finn, question for you, I think. Given the transformation is deterministic, how does it protect against the reverse engineering of the data?
Yeah, no, great question, and we get it all the time. So there's two parts to it. Excuse me. So I think it's important to understand the nuance between synthetic data and masking. So when we're doing synthetic data, everything is being generated from Synthesize, like from scratch within Synthesize. So even though it's learning from the patterns and distributions, nothing is sensitive is being brought over or transformed. So from that point of view, there's no way to do any kind of reverse engineering because nothing's actually being sort of transform one-to-one. With masking, it's the opposite. Of course, we are literally taking a value and transforming it. It's a one-way transformation, and the only way that you would be able to get back to the original value is if you already had access to the data in that source. So, you know, if I already had access to a customer database and I knew there were 1,000 accounts with, you know, the first name Finn, yes, okay, if then the target there were 1,000 Williams, I would be able to make that assumption. But, you know, that is the assumption is that you would already have access to data that you shouldn't. And so, yeah, that's the only way you'd really be able to do it. That there's no way of being able to sort of unravel the algorithms that we have. It's a one-way transformation.
Are there any other questions? Well, if there are no other questions, again, I appreciate everybody joining today and listening to me and Finn talk about supercharging AI with test data automation. I hope it was useful for everybody listening in, and you understand a bit more about your obligations when it comes to NIST2 and the other regulatory landscapes.
That's a wrap. Thank you very much.
Brilliant. Thank you all.
We good to drop, Catherine?
Thank you, Leo. Yes.
Thank you. Thanks to everybody. Bye.